Hi, in the last video we discussed about object identity and we saw few examples for understanding how an object ID can be traced. In this video we are going to see few more examples to understand more in detail about tracing out an object's ID. So let's go direct into the demonstration. Here I'm going to create a couple of variables. Let's say a variable name called age1 equals 25, and I'm going to have another variable name called age2 equals 26. Now we have two variables assigned with the value of 25 and 26 respectively. Let's go ahead and print the ID of this variable so that we can trace the identity of the object. Age1, which is a symbolic name, and age2 is another symbolic name representing the respective objects, integer object. If I execute this, you can notice that there are two ID have been printed and their ID are different, means they are unique. They are not same. So in memory, there are two objects are in existence and each object carries its own ID. So that's the conclusion of this snippet of code. But when I'm having a similarity of value between these two variables, like for example 25 and 25, if you notice, then what will happen here is the IDs are going to be same. Why? Why is that the IDs are same here? It's because the values are same. So Python will make sure if the values are same for two different variables, then it will create a single object, and in that single object the value will be placed, and both the symbolic name called age1 and age2 will point to the same object. Instead of creating two different objects, it will create a single object since the values are same. If you notice here, the values are same. So it will create a single object, and by that way it ensures that your ID is referred to that particular object, and both the age1 and age2 are referring to the same ID of the object. Now coming to this understanding, we can clearly identify that when the values are same for two different variables also, the object creation in the memory is going to be only one. But there are certain rules for this implementation. What are the rules? The rules are when you are having similar values for two different variables, if it is a numerical value, the range is 0 to 256. In this range of values alone will be considered for a single object creation. What I mean by that is, if a value crosses 256 or if the value is less than 0, then you will have a unique object to be created for individual variables even though the value is going to be same. Let's see an example for that to understand. So right now you keep in mind that the range is 0 to 256. So 25 falls within the range of 0 to 256, so that the number of object that's created here is a single object and the value that's stored in that particular object is 25, and there are two symbolic names are pointed to the same object itself, and so you seem to have the ID output as a same ID because both are pointing to the same object, right? So in that case, there is no need for carrying another object in it. That's how the Python works. But noticeably, this particular value, that's 25, is coming under the range of 0 to 256. That is a noticeable point. Now, when we have a value which is not falling under this range, okay, when we have a value which is not falling under that range, then how the object creation will happen? That's what which we are going to explore right now. So let's go back and change this value to 256, and here also it's 256. If you execute, you will see that the ID is going to be same because the values are falling under the range of 0 to 256, inclusive of 256, inclusive of 0 to inclusive of 256. That's the range. But the moment I say 257, okay, when I say 257, when we cross the range, if the values are same for a couple of variables, the Python interpreter will not hold a single object, rather it will create a two different object even though the values are same. It will create a two different object in a memory and it will assign a two different unique ID. Now this age 1 is pointing to a specific memory where the value that's there in it is 257. So let's change this value to 257. Okay, 257. Now what happens is this particular age 2 is not going to point to this memory. Instead, it's going to point to another object where in that object again the value is 257. Why? Because the 257 doesn't fall under the range of 0 to 256. So the Python will create an individual object for it. The same happens if the value is less than 0 also. When you take a negative value and if you have a same negative value for both the variable, the objects will be two different objects. But whenever in Python environment, the interpreter environment, when your values are same between the variables, and if so those values are falling within the range of 0 to 256 inclusively, then the object creations will be only 1. This is a very much important range of values which have to be understood clearly. If in case if they are different values, then obviously the ID is going to be different. So right now it's 256 and here again it's 256. The values are falling within the range, so the ID is going to be same. You can see that, right? The IDs are same. But if I have 254, even though within the range if they come, but the values are different. When the values are different, then obviously your ID will also be different. When IDs are different, then you can notice that there are two different objects in the existence. There is a meaning. So age 1 points to an object which carries 256 in it, and age 2 is pointing to another object where it carries a 254. Then each object takes its own unique ID in it. Now the same approach we have to see how it's going to work when it is going to be a floating values. Do we have a range for floating values? Obviously not. We don't have any specific range for floating values. So how the object reference happens for a floating value? We will explore that as well. So I'm going to create a new cell for defining the object reference for a floating type of object. Here I have a pi value where pi equals 3.14, and I have another variable called pi2. Pi2 is also going to have 3.14. Now the values are same. Please be noted, the values are same. When the values are same, and if I'm trying to trace the ID for it, pi1, I'm sorry, it's for pi2, you get an ID for that particular object. Okay, if you notice this, print of type of pi2. So we'll get to know the type. The type is a float, right? It's a float type of object and the ID is assigned. The same way, if we have to note down for print of ID of pi. Now there are two ID have been generated and both the IDs are unique. So when it comes to the floating object, okay, when the values are same, there is no range appearance for it. So any floating value, when the values are same, the interpreter, the Python interpreter, will create two different individual object, always two different individual object, and place the value, the respective values in it, and the symbolic names, that is your pi and pi2, will point to the respective object. And so you get a two different unique ID for those variables. So actually these are your identity of the object, and the identity of the objects are different. So only for the integer, only for the numeric, you have a specific range. Only for the numeric, you have the specific range between 0 to 256. Please be noted, if I have a value of 0 here for integer type, and if you try to figure out the ID for it, it's going to be same because it falls within the range of 0 to 256. But when I give a negative value like minus 15, and here again I go and define a minus 15 as in a value, then in that case it's not coming within the range. So if the values are same and if it is a negative value, still it will go ahead and create a two different object. So the object IDs are different. But when I have minus 17, altogether the values are different. So when the values are different, you cannot store two different values in a same object. So obviously you need two different objects in it. So this is a negative value. So again, the objects are different, object IDs are different. So the rule of carrying a single object for a same value is only for within the range of 0 to 256. Please make a note of it. So for floating, there is no such constraint. Any value you give, okay, it could be a same value or it could be a different value. Always for floating object, the Python interpreter will create a different object for it. So 3.15, 3.14, two different values, so two different object in the memory. If it's 3.14, same for both the variables, but still it will go ahead and create two different object for it because these are floating expressions, right, where it carries a decimal values in it. So obviously we cannot expect creating a single object for it. So such rules are not applicable for floating object. Now the last thing that we have to discuss is for Boolean. So we saw for string, we saw for the integer, we saw for floating. Now it is the time to see the Boolean values. So I have a variable called truthy, and I'm going to define a value called true. And I have a variable called falsy, and I'm going to declare a value called false. So by this way, if you approach for tracing the ID of these variables like ID truthy and ID of falsy, we will get a two different identity for the particular object. So there are two objects in the existence. One is referring to a truthy object, another one is referring to the falsy object. Truthy and falsy are the symbolic names. So we go ahead and trace the object ID. So if you look at the object ID, it is unique. So why it is unique? Because the values are different. It's 640 and 656 is the ID. So there are two objects and the values are stored in that respective object, true and false. By this way, we ensure that we have a symbolic name called truthy pointing to that specific object, and we have falsy which is pointing to that respective object location. Now, what if in case the values are same? Are they going to treat it as a two different object or the same object? That's what which we have to figure out now. So for falsy also, I'm enforcing with true. So when I'm giving true here, and if I execute, you can see that the IDs are same. Okay, why the IDs are same? Because the values are same. So for Boolean expression of object, if the values are same for two different variable, Python interpreter will practically create a two different object and store that respective value in that. It will create a single object and store that true or false value in that particular object. So in this case, since the values are same, we are not going to have the false C variable to be pointed to a separate object. Instead, it's going to point to the same truthy object itself. Okay. So truthy and falsy points to the same object, and so the object IDs are same for them. It's same. It's not unique, right? So this is a noticeable point when it comes to the Boolean object. So the conclusion here is, for string, for integer, for Boolean, when the values are same, it will create a single object in the memory. But for integer, the relaxation is for 0 to 256 alone. For 0 to 256 range of values alone, if the values are same for two different variables, a single object creations will happen. If it's less than 0 or greater than 256, we'll enforce creating a two different object for it. When it comes to Boolean, when the values are same for two different variables, the object is going to be a single object in the memory. And if the values are different, obviously it will create two different objects. But floating is completely different from all these type of object. For floating, whether it is the same floating value or different floating values, when the variables are carrying a same or a different values, doesn't matter. Irrespective of what shape of value you have in floating, it will always keep creating a new object for every variable, individual object, so that those individual objects IDs will be always unique when it comes to the object of float. So with this, we end up this session of tutorial, and we will see the next discussion of object reference in the next video. Thank you.